So here is another session based on mathematics, and this time around we are going to do a topic which is very simple, vector geometry. So we have a question here which is going to help us to understand more concepts that we can learn from this particular question. So here is the statement of the question which is saying Q is the midpoint of OC. So this Q is the midpoint of line OC. If Q is the midpoint of line OC, this simply means that OQ is equal to QC. OQ is equal to QC. And this signifies to say vector Q on OQ is also the same vector on QC. So here I need even to indicate to show to say I'm expressing and understanding what we call the statement of the question. And OA is equal to AB. Vector OA is equal to vector AB. And BP. So definitely we are saying if OA is equal to AB, if OA is vector 2P, definitely on AB it will also be vector 2P. And if AB is equal to BP, definitely on BP it will also going to be vector 2P. Now, after doing the analysis of the question, therefore you need to go to the main statement of the question so that you can express vector P in terms of vector Q, which is vector OB. So now the first question we are going to do is say find or express vector OB. So moving from O going to B. We are moving from O going to B. We are going to say since OA is equal to AB, definitely we can create a simple root which is going to help us to understand. We are going to say OA plus AB, just a direct root. OA plus AB. This will be the root that we are going to create. When we create this particular root, because we are given the statement to say OA is equal to AB and AB is equal to BP. Definitely, where there is OA, I'm going to pick vector 2P plus where there is AB, I'm going to pick vector 2P. So definitely, I'll add this to be 2P plus 2P, it will be vector 4 vector P. So this is the expression of vector OB, which is 4P. This becomes the expression of vector OB. So just as simple as that, we have found the answer without even using a calculator. That is the reason why I was saying vector geometry is one of the simplest topics in mathematics. So enjoy the next one. So we are moving from A, we are going to Q, which is AQ. So now let us find the solution to vector AQ. So vector AQ, definitely I can express my answer here. This is vector 4P as the final answer on that one by using this simple root we created, which is OA plus AB. Now we are changing, we are going to go to Roman numeral 2, which is saying AQ. So we are moving from A coming to this point Q. So now here we need to move in a triangular way or in a triangular formula where we need to say moving from A going to Q, moving from A going to Q, we are going to say we will create another root. So we are going to say Roman numeral 2 AQ. We are moving from point A going to point Q. Here we are going to say AO plus OQ. AO plus OQ. So this is the root that we are going to create. If we want to find the expression in terms of vector P or vector Q of saying AQ, we need to say AO plus OQ. And we are going to go against the direction here. Definitely, this positive OA, which is vector 2P, will be affected by a negative just by showing and expressing it to be negative 2P plus OQ, there is vector Q there, so which is a positive vector. Now, there are certain teachers and some certain books of mathematics which doesn't have a quick expression based on having a negative in front of the expression. Therefore, we can express this in terms of a positive vector just by getting a vector Q to put it in front here so that this one can create a negative vector 2P. just by doing it in this way. We have the expression for vector AQ. We have the expression for vector AQ moving from A going to Q. So we have the expression for vector AQ, which is Q minus 2B. Very simple. So we can show it somewhere here. We can show it somewhere here. So we have Q minus 2P. Very simple. So here we add BC. Then from there we add definitely the word marking for CP. So we are changing now. We are going to move on what we call vector BC. So definitely we can express the interest onto vector BC, which is our Roman numeral 2. So we are going to say vector BC, meaning we are moving from point B going to point C. Moving from point B going to point C. Our B is here, letter C is here. So we are going to say, moving from B going to C, we can say B O C. We can say B O C. So this is the expression of the root that we are going to take when we want to find the expression of a vector BC. We are moving from B O C. So now, if this is the expression of the root that we are going to take, therefore BO, we are going to go against the direction. But remember to say BO, we have a 2P here, which is BA, a negative 1. Again, we are going to create another negative. Definitely, we are going to say BO will be negative 4 vector P plus what? OC. So now we have OQ plus QC, which is going to give us 2Q. So definitely, having a negative in front of the expression, we can change it to be positive 2 vector Q minus 4 vector P. Just as simple as that. We have another solution for the expression of a vector BC. So we are done with this expression of vector BC, which is 2Q minus 4P. Very simple under vector geometry. You don't even have to stress by looking for a calculator. You just have to solve directly under what we call algebraic expression combination with what we call vector geometry. In this case, we have BC, which is very simple, 2Q minus 4P as our final expression for vector BC. So now we can go to the last one. The last one is saying we need to have the expression for CP, moving from C going to point P. So if we are going to move from point C going to point P, we are going to create a root that is going to be, we can either say CO plus OP. So we are going to say CO plus OP. So if you create this type of a root, where are we going to get the expression? Remember that we have what we call BC. We have BC, which is the answer that we got here. Though this time around, we can't go by that route of using CB and BP. We can get the same answer, but we can just go by using the direct route so that we can get the final answers. So now we are going to say CO, we are going to go against this direction. So if this is 2Q, we are going to get a negative 2Q. So we have negative vector 2Q plus. So when we have negative vector 2Q plus OP, from O to P, we are going to get, if this is 2P plus 2P plus 2P, we are going to get 6 vector P. And remember about the effect of a negative, so definitely we can get this to be 6 vector P minus 2Q. Just as simple as that. We are done with the introduction to the expression of what we call vector geometry. In this case, you can understand the first concept of triangular root formation under what we call vectors. And it's a bye-bye for now. You can stay tuned, follow the page.